In this video, we shall discuss about chi-square test, which is the most important statistical part for MSc Mathematics students and research-oriented students in their respective master degrees. Before looking into what is chi-square test, we have to know what is parametric test and non-parametric test separately. Parametric tests are those that make assumptions about the parameters of the population distribution from which the sample is drawn. Example, t-test and ANOVA test. Next one is non-parametric test. Non-parametric tests are not based on the assumptions, that is, the data can be collected from a sample that does not follow a specific distribution. Example is chi-square test. So we conclude that chi-square test is one of the non-parametric tests. Now we shall see what is the definition for chi-square test and its related formula. A chi-square test is a statistical hypothesis that can be used in the analysis of contingency tables when the sample size are large. Chi-square is denoted by x square symbol. Chi-square equal to summation O minus C the whole square divided by E, where O denotes the observed frequency of sample and E denotes the expected frequency of sample. Now we shall solve a simple problem based on this chi-square test. A company keeps records of accidents during a recent safety review. A random sample of 60 accidents was selected and clarified by the day of the work on which they occurred. Day are given as Monday, Tuesday, Wednesday, Thursday and Friday. Number of accidents in the respective days are 8, 12, 9, 14 and 17. Test whether there is any evidence that the accidents are more likely on same days than others. So we have to find whether the accidents are uniformly booked on all those days. Solution: H naught equal to accidents are equally likely to occur. Here H naught indicates the null hypothesis. In the null next one is H1 alternate hypothesis. Alternate hypothesis is the reversal of null hypothesis. So H naught we have taken accidents are equally likely to occur. H1 represents accidents are not equally likely to occur. Both of them are contradictory to each other. Now expected frequency I have to find by using adding all the number of accidents, that is 8 plus 12 plus 9 plus 14 plus 17, and divided by number of accidents 5. So 60 divided by 5 is 12. Now I am going to create a tabular column. First I am writing the values for O separately. O denotes the number of accidents 8, 12, 9, 14 and 17. E denotes the expected frequency. 12 remains same for all those observed frequency. All those values we have to write 12. Next one is O minus E. That is for each column we have to find the separate O minus E value. 8 minus 12 is minus 4, 12 minus 12 is 0, 9 minus 12 is minus 3, etc. and so on. Next to O minus E the whole square. Minus 4 the whole square is 16, 0 square is 0, minus 3 the whole square is 9, etc. and so on. Next I am going to find O minus E the whole square divided by E. For each O minus E the whole square value has to be divided by E value. 16 by 12 is 1.333 and 0 by 12 is 0, 9 by 12 is 0.75, etc. and so on. Now chi-square equal to summation O minus E the whole square by E. I have to add all the O minus E the whole square divided by E and divide it by E value. E value remains same, that is 12. So the answer is 4.499. Next I have to calculate degrees of freedom. Degrees here the distribution is actually binomial distribution because the accidents are uniformly occurred on all those days. So the distribution follows binomial pattern. For binomial pattern, degrees of freedom is n minus 1. N here the value is number of days 5. So 5 minus 1 gives 4. That is the degrees of freedom. This degrees of freedom 4 I have to refer the chi-square table which will be provided. In that chi-square table, that 4 degrees of freedom I have to uh, find the corresponding 5% value. 5% value in that chi-square table. I will be getting 5 point or 9 point something in that table. Next, I have to find calculated value. Calculated value means the value which we have calculated using the formula, that is 4.499. So in this problem we will find that table value will be greater than the table value will be greater than the calculated value. Table value means the value which we have referred using the table. That value will be higher than the calculated value 4.499. So in the suppose if the table value is higher, the case is there is no significant difference and null hypothesis is accepted. In case if we have the table value is lesser than calculated value, we have to take in the reverse way, there is significant difference and null hypothesis is rejected. But in this problem table value is greater than calculated value, so we will conclude that there is no significant difference and null hypothesis is accepted, which implies accidents are equally likely to occur on all those days, that is from Monday to Friday. Check. Thank you.